All right, 10 points if you can tell me what movie this is from.
Oh, great Odin's Raven.
Write it down.
Can you do it again? Keep on playing it.
Oh, great Odin's Raven. Oh, great Odin's Raven. Oh, great Odin's Raven.
Green correct. Purple correct. Blue correct. Orange incorrect. I won't count off for it. Pink incorrect. I won't count off. I won't count off for TV question. Anyone else?
She wrote Iron Man. I wrote Camp Rock 2.
That was Anchorman.
Wait, I put Shrek. Never mind.
Shrek isn't right.
I knew it was Luke.
All right.
I put Camp Rock 2.
Okay. You want to get where you can take notes now? But stay with your group. Can you do that? Can you do both those things?
Yep.
Yes. Stay with your group and take notes. No, hang on.
You do that.
I might ask you more questions.
I'm just gonna bring the
All right, so just a quick review of what we did yesterday. Are we filming that?
Mm-hmm.
Sweet. Can you get the screen?
Mm-hmm.
Quick review of what we did yesterday. We know water is transparent. Light can go through it. That's helpful to underwater plants. Water is blue. It does absorb some of the red, and so it makes it look blue. We know that water is a polar molecule. That means that it's charged. The oxygen is partially negative. The hydrogens are partially positive. Remember that from yesterday? The whole water molecule is a charged molecule. This is review from yesterday. Water sticks to one another. It's cohesive. It sticks to one another using hydrogen bonds. Remember that from yesterday? Did we do this yesterday?
Yes.
Mm-hmm.
Y'all aren't saying you remember it.
I remember.
Remember it. Ha.
Water is a good solvent. If you put salt or something in water, it'll break it apart. Did I pour some salt into water last time for y'all?
No.
No, you poured water everywhere.
I poured dumped water everywhere, that's right. We'll dissolve some salt in the lab in just a few minutes here. That'll be fun. You can see water forms droplets because it's cohesive. It sticks to itself.
Cohesive.
That's cohesion. Water has a high surface tension. This bug is able to walk on water. You know what kind of bug that is?
It's a Jesus bug.
Yes, Ashley?
A water strider.
It is a water strider.
Good job, Ashley.
Now, I want to talk about capillary action. Water is also adhesive. Have you ever heard the word adhesion?
Yes.
That means to stick to something. Since water is a charged molecule, it'll stick to anything that's charged. So if you take a thin tube, like this represented here, these two things represent thin tubes. If you stick it in some water, the water will run up along the sides of the tube if the sides of the tube are charged. So if you take a glass tube, and we're going to do this in the lab too. If you take a glass tube and you stick it to the surface of some water, the water will run up the tube a little bit because it's attracted to the glass because the glass is slightly charged. The thinner the tube, the further the water will go up it. So that fat tube, water goes up it a little, but the thin tube, water goes up it real far. There are tiny little tubes inside your body carrying water right now. You know what they're called?
Veins.
Yeah.
Is it right?
Veins and arteries, blood vessels. They're carrying blood, which is mostly water. And it helps the blood move through the tubes. The fact that the blood is attracted to the walls of the tubes helps it move. There are tiny little tubes in trees. They're called xylem cells that allow the water to move up to the top of a tree. You ever wondered how water gets from the ground up to the top of a tree? One way is through this adhesion to the walls. It helps it go up the tubes. Y'all know what that little dip is right there? That has a name, the little dip that you see in the middle of the tube. Anyone know that name? 10-point bonus for your team if you know that.
Trough. The crest.
It's a good guess. A trough is a good guess, but it's not. That little dip right there has a name.
Is it really specific?
Yeah.
Oh.
It's a specific name.
Is it like
I
a
thought you
big
might have
one?
learned it.
Circulation.
It's called a meniscus.
Yeah, I know.
Can you say meniscus?
Meniscus.
Nice.
That will be bonus question or something?
Nah, it's just something I thought of.
I wouldn't know how to spell it.
Neither would I.
Meniscus.
Water has a high specific heat. That means it takes a lot of energy to heat up water, and water tends to stay at that temperature for a long time. Now, something you have to learn about molecules is the faster they move, the hotter they are. That's what temperature is. It's a measure of the speed that the molecules are moving. Did y'all know that? If something's warm, that means the molecules are moving fast. If something's cold, it means they're moving slow. If something's real hot, the molecules are moving real fast. Did you know that all molecules are always moving? Even the molecules of this desk are moving right now. Because I know that because the desk isn't real cold. So they must be moving. They're vibrating. If you touched the desk and it was really cold, you would know that the molecules aren't moving very fast. If you touched the desk and it was really hot, you would know the molecules are moving real fast. If you take a piece of metal and you get it hot enough, the molecules move so fast that they spread apart from one another and the thing will melt. Isn't that cool? And if you got it even hotter, they would turn into a gas. Y'all know about solid, liquid, and gas?
Mm-hmm.
So this is a chart showing that water, when it's real cold, is ice. But if you give it more energy, that's what this axis is. Have y'all seen graphs before? You're gonna see a lot of graphs in biology. You got to be able to read a graph. So on the bottom here, this says enthalpy change. This really means energy, is what this is talking about here. So as you add energy to the ice, the temperature goes up. More energy, higher temperature. And as you start adding energy to ice, it gets warmer and warmer. You don't think of ice getting warmer, but ice can be really cold, negative 100 degrees Celsius. But you can get it warmer and warmer and warmer. And then once it reaches 0 degrees Celsius, the ice will start melting. And it'll turn into liquid. You know what we call liquid ice?
Dry.
Water.
Oh, what a mind buster.
And then as you add more energy, the water becomes warmer and warmer and warmer, and eventually when it reaches 100 degrees, guess what happens to the water?
It
Turns into
gas.
It turns into gas or steam. But you have to give it a whole lot of energy to convert it from water into steam. Why is that? It's because water molecules are held together with hydrogen bonds. That bond there that holds this water molecule to this water molecule, remember yesterday we talked about that? That's called a hydrogen bond. That's strong. And it keeps the water molecules from separating. So you got to give a whole lot of energy to go from water, which is molecules close to one another, to steam, which is the molecules just flying off in every direction. So look at all the energy it takes to go from liquid all the way to gas. You got to give it a whole bunch of energy. So we say that water has a high specific heat. Specific heat refers to how much energy you got to give it to change temperature. Make sense? So, and you can look at this graph to answer this question. 10 points if you can tell me what it's called when you go from liquid to solid. What is that called? 10 points if you can tell me. What is it going from liquid water to solid ice? What's that
Freezing.
process called?
I learned this.
Vacation.
Condensation.
10 points, you gotta write it down, don't yell it out.
Liquid to solid?
From liquid water to solid ice.
They bring it up to you.
What's the name of that? Yeah, bring it up here.
Good job.
Oh, wait.
There's a rainbow.
Wait, where is it?
Liquid water to solid ice.
Thank you.
There's a name for that process.
Can I
Green
use,
got it right.
can I use an orange sheet?
Anyone else?
What do you think it is? I didn't.
I don't know. All I know is
I'll
I
give
got
you
it's
a
a
hint. It's up there
rainbow.
somewhere.
Write it down.
Blue correct. White correct. Anyone else?
Yes. I think I did.
Purple correct. Anyone else?
Wait. We have to write it down.
Wait, can you repeat what you said one more time from liquid
If water goes
Wait,
from
that-
liquid water to solid ice, what do we call
Comes
that?
off, like, and like.
Wait, is it?
Anyone?
Yes. Follow that.
Going.
Go away.
Orange incorrect. It's called freezing.
Oh my god.
It's called freezing. See, it said right there, not freezing. Melting is going from ice to liquid. Freezing is going from liquid to ice.
I blame
Right?
global warming.
You
Wait, where
freeze
were we going?
Water forms ice.
What were we? What?
Oh, wait.
So, let me ask you this one. What is it called if you go from gas to liquid water? 10 points if you can tell me what that's called. See if you can read this chart. I'll give you a hint. It's on the screen. Going from gas to liquid water.
No.
No.
You got to be able to read charts. Yes. Pink is correct.
Oil. No.
Green is correct.
Do condensing.
Purple's correct.
Condensation.
Anyone else?
Here, wait.
Going.
Wait. Here,
Wait.
you write it. I just put color.
Orange correct. Orange, you glad I didn't say banana?
Yeah.
A little bit, actually.
Blue, I can't give it to you right or wrong. White is correct.
I try to scratch out more.
Kobe.
Blue correct.
You ready for this, Kobe?
I'll try to scratch
It's called condensing. See, condensing? If you go from gas to liquid, that's condensing. If you go from liquid to gas, what is it? Boiling.
Wait, did Orange
That's
get
a
it
fun
right?
chart. Make sure you can read these charts that are in your book. You gotta look at them, think about them. This is what the molecules of water, of H2O, look like when water is frozen. That's what ice looks like if you could see the molecules. They take on a nice regular arrangement. You see how it looks like a bunch of hexagons with space in between?
Like a snowflake.
Yeah, it does. It looks like a snowflake. This is what water looks like when it's liquid. There's no arrangement. It's all haphazard. The molecules are moving and they're kind of rolling over one another. But when you freeze the water, you slow down that molecular movement and they'll take on this arrangement. So it looks like that. And what's cool about it is this frozen arrangement is less dense than the liquid arrangement. Ice is less dense than water. Did you know that? You know what dense means?
Yes.
Dense means compact. ice is less compact than water. Ice floats. You ever notice ice floats? You might have seen an iceberg on TV. That's floating. Has anyone ever seen an iceberg in real life? You have? Where'd you go?
Alaska.
Did you? Saw icebergs floating around? I bet the water was cold.
I think they're partially underwater.
Yeah, they were actually mostly underwater. That's just the tip of the iceberg. You ever heard that statement before? It's probably real big underneath it. Anyway, that's an important thing about water is it's less dense when it freezes. The hydrogen bonds between the water molecules make the molecules line up in this regular arrangement. But if you get the ice hot enough, the molecules move fast enough, they won't line up anymore and they'll just be jumbled up. But if you cool it off, the molecules slow down and take on this regular arrangement, and all of a sudden the ice expands. Have you ever taken a bottle of water and put it in the freezer and accidentally left it there too long? The water will expand and break the bottle. Freezing ice is a really important force of nature. It'll break rocks. It's called freeze-thaw. And if you get a little water in a crack of rock, and then it gets cold, that water freezes, it'll break the rock in half. It's one of the things that causes erosion on our planet. Freeze-thaw. Every year you get freeze, and then it thaws out and freezes again, and it'll crack rocks, break them down into little tiny pieces. Isn't that crazy?
Is that why the roads crack?
Yeah, that's exactly why roads crack. Mm-hmm. You get a lot less cracked roads in Georgia and Florida than you do up in Boston and New York and places where it freezes every year. We don't get much freezing, so we don't get much freeze-thaw. We don't have to spend as much on our roads. Did you know Georgia has the #1 roads in the country?
Wow.
We have the best roads.
Wow.
And part of the reason is because we're in the South and it doesn't freeze much. So, how does that help living things? Well, let's think about a lake. I'm going to draw a lake up here. Imagine a lake.
It's not the face.
You like my lake?
Yeah.
Wait.
Here's the ground here, and here's a lake, and let's pretend there's a fish in it.
Birds.
There's a fish, and he's happy.
And
And now let's pretend this is a lake up in the northern United States somewhere, in Michigan, or somewhere where it gets real cold. And you get cold air coming in here. And all of a sudden the lake will freeze. But only the top part of the lake freezes, because that's the part that's touching the cold air. And the top will freeze, and you'll get a layer of ice on the top of the lake. Now the thing about water is, when water freezes, it expands. And so it gets lighter and floats. If it didn't do that, if it froze and got heavier and sank, well, eventually the entire lake would freeze solid. If it sank, and then the next part froze and sank, and then the next part froze and sank, eventually you get layers and layers of ice on the bottom, and eventually that fish would freeze.
Oh.
That's a frozen
Recorded
fish.
by a potato.
Like this. 'Cause he's
Just like
frozen.
recorded by a potato.
But that doesn't happen. The frozen water floats, and the ice stays on top, and it never freezes down here. And all this water down here is insulated and protected from the cold air by this layer of ice. And the fish never freezes, and he can go on about his business, being happy like he was. And unless you go ice fishing. Anyone here ever been ice fishing? You cut down. You've been ice fishing too? Did you do that in Alaska also? You cut a hole. Lachlan cuts a hole there and drops a fishing line in there. And he eventually, I'd sit and he dies anyway. Either way. Okay, so it's important for living things that ice floats. That preserves all the organisms in lakes and also in the oceans near the poles where the water gets real cold. That would all be frozen, we would live in a very different world if ice sank when it got colder. But it doesn't, it floats. Isn't that cool? So make sure you read all about these different properties of water. There's probably going to be a quiz on Chapter 2 tomorrow when you come in, so make sure you've read that. And what I want to do is I want to take you in the lab here and I want to show you some of these properties. So you can turn off the filming.